Assalamualaikum and hi guys. So in this video you will learn about types of the first order differential equation. So there are 4 types: separable, homogeneous, linear and exact equation. So in this video you will learn about a separable equation. So for separable equation, so the differential equation is said to be separable if the equation can be written as a product of a function which is in terms of variable x and variable y. So for example, you have dy dx is equal to ux multiply vy, which is ux is any function with the variable x multiply with any function of variable y. So we need to separate the variable so that the variable y on the left hand side and the variable x on the right hand side. After you have separate the variable, then we need to integrate for both sides in order to solve this differential equation. So you need to separate, or you need to make sure that all the variable x is on the left hand side and all the variable x on the right hand side so that you can integrate after that. Okay, so we proceed with this example. Solve the given differential equation by using separable. So x plus 2 dy over dx is equal to y. So if we refer here, the variable x is on the right hand side and we have the variable y on the right hand side. So we have to separate the variable. Okay, so you have to separate so that your x on right hand side, your y on left hand side. So in order to move the x plus 2, okay, so we have x plus 2 is in terms of multiply, so we need to move to the right hand side, so it will become divide. So x plus 2 dy over dx is equal to y over x plus 2. So now the variable y here, you need to move to the left hand side. The y here is in terms of multiply, so when we move to the left hand side we become divide. So the divide here, make sure you write in terms of 1 over y dy over dx is equal to 1 over x plus 2. So we still have the variable or the derivative of dx on the left hand side. So move this dx to the right hand side, so it will become multiply. So therefore you will have 1 over y dy is equal to 1 over x plus 2 dx. So now we check all the variable y on the left hand side and all the variable x on the right hand side. So now we can integrate for both sides. Integrate 1 over y dy is equal integrate 1 over x plus 2 dx. So integrate 1 over y will become ln y. Integrate 1 over x plus 2 will become ln x plus 2. And then we put the plus c here. So plus c only exists for the right hand side. Okay, so make sure when you integrate 1 over y, it will become ln y. So the concept here, actually you have to divide with differentiate the argument here in the bracket, which is y. The same thing for the right hand side, you have to divide with differentiate the argument d over dx x plus 2. So when we differentiate y the power of 1 will become 1. Differentiate x plus 2 will become 1. So therefore your final answer is ln y is equal to ln x plus 2 plus c. Okay, so this one there is no problem because it's only divide by 1. Let's say we have integrate 1 over 2x plus 3 dx. So this one will become ln 2x plus 3 divide with differentiate the argument, which is 2x plus 3 will become divide with 2, because differentiate 2x plus 3 will become 2. So that's why you have to be careful in terms of differentiate the differentiate the argument, put at the bottom here. If only one, there is no problem, but for here we have 2x, so it will become 2 at the bottom. Okay, so that is how we are going to solve for the separable equation. The first step is you have to separate the variable. Once you have separate the variable, then we need to integrate for both sides. Okay, so for this example, we only apply a direct integration. So now we go for the second example. Solve the following separable equation, whereby you have exponent x dy dx equal to x plus 5 over 2y. X dy over dx x plus 5 over 2y. Okay, so the same thing, you have to separate the variable. X on right hand side, y on left hand side. Okay, so now we move exponential x to the right hand side. Exponent x is in terms of multiply, so we move to the right hand side will become divide. Dy over dx is equal to x plus 5 2y multiply exponent x. So now we have the variable y on the right hand side. Move the 2y to the left hand side will become multiply. 2y dy over dx is equal to x plus 5 over ex. So on the left hand side, you still have the dx. Move dx to the right hand side will become multiply. Okay, now all the variable has been separated. X on the right hand side, y on the left hand side. Now we want to integrate. Integrate 2y dy is equal to integrate. On the right hand side, we have exponential at the bottom side. So this exponential, you need to bring to the upper side. So exponent x bring to the upper side will become e negative x, x plus 5 dx. Okay, integrate for both sides. Integrate 2y dy will become 2y square over 2. Equal to, integrate the right hand side. Exponent multiply with the polynomial, we need to apply tabular method. Okay, so in order to apply the tabular method, you have to arrange in the context of tabular form. You must have u, you must have the dv. Our u is the polynomial x plus 5, the dv is e negative x. So this polynomial or u here, you need to differentiate until you get the value of 0. So differentiate for the first time is 1, differentiate for the second time will become 0. The dv here, exponential of negative x, you have to integrate until you get the same level of 0. Okay, so integrate e negative x over d over dx negative x. So I just write one by one. So this one will become e negative x over negative 1. So integrate one more time. E negative x over negative 1. Differentiate the power. You will have e negative x over 1. Why 1 here? Because we have negative 1 multiply with the negative 1. So now we want to combine all the answer. The first layer multiply with the second layer. Second with the third layer. Positive, negative. Okay, now combine all the answer. X plus 5 multiply negative e negative x. X plus 5 multiply negative e negative x with a positive sign. For the second one, 1 multiply with the e negative x. 1 multiply e negative x with a negative sign. And then you need to plus with the constant of c. So simplify all these things. 2y squared over 2 will become y squared. X plus 5 negative e negative x minus e negative x plus c. So this is what we call as general solution. Okay, for this question, you are given the initial condition y0 equal to 1. So this condition is for you to find the value for the constant of c. Use condition y0 equal to 1 to find c. So this is the c that you need to find. So from the given condition y0 equal to 1, so the position of 0 here means that x is equal to 0. The 1 here is y is equal to 1. So therefore, substitute the given condition to our general solution. So this y square will become 1 square 0 plus 5 negative e negative 0 minus e negative 0 plus c. So exponential of 0 or exponential of negative 0 is equal to 1. So simplify. 1 is equal to 5. 0 plus 5 is 5. Negative exponent 0. Negative 1 minus 1 plus c. So therefore our c will become 5 multiply negative 1 is negative 5. Minus 1 will become negative 6. Negative 6 plus with 1 will become 7. So your c is equal to 7. Once you get the value of c equal to 7, you need to substitute back to the position of c. Therefore, our particular solution is y square is equal to x plus 5 negative e negative x minus e negative x plus 7. Okay, so that is the answer for the particular solution. So remember, if you are given the condition here, you need to proceed to find the value of the constant c.